Okay, today we're going to be talking about writing equations of absolute value graphs. Some things to remember about the absolute value function: it is V-shaped, so that's how we're going to know that we're dealing with an absolute value graph. The vertex is located at 0, 0. That's important because we're going to be using that as a reference point. And then typically when we move right 1 unit on the absolute value parent function, we have to move up 1 unit to get to that next point on the graph. That is another reference point that we're going to be using when we go to write the equation of the absolute value graphs. Also, something to keep in mind, our parent function looks like y equals the absolute value of x, or f of x is equal to the absolute value of x. When we transform absolute value functions, we can stretch or shrink the graph, also cause a vertical reflection by changing the value out in front of the absolute value. That's the a value. Inside the absolute value signs, we can shift the graph left or right. That's a horizontal translation. And remember, the sign that you see is the opposite of the direction that we would move. And then outside the absolute value function, k shifts the value up or down. So that's a vertical translation. We're going to take a look at this first example together, and I'm going to walk you through the steps to writing an equation of an absolute value graph using these transformations. So the first step that we need to do is to locate the vertex of the graph. Normally the vertex of the graph is located at 0, 0, but because we're shifting graphs, it may not be located at 0, 0. With this one, the vertex is located right here. So if we think about how we would get there, we've moved right 2 units to get to that new vertex. A right or left shift affects the value of h. So in this case, h is 2 because we moved right 2 units to get there. We do not have to move up or down at all to get to the vertex. So we do not have a vertical translation. So there's no up or down movement. So k is 0. To determine if there's a shrink or a stretch, you're always going to move from the vertex right 1 unit. And then the vertical change is going to allow you to see the value for a. So that vertical change here is 1. So my a value is 1. Plugging those values into our equation, we have y equals a, so 1, times the absolute value of x minus h is 2, plus k is 0. We can clean that up a little bit by simplifying some things. 1 times anything is just itself, so we really don't need to write this 1 out front. So y equals the absolute value of x minus 2. And then adding 0 to something, again, does not change the value of that item. So we really don't need to write the plus 0. So we have the equation y equals absolute value of x minus 2, or in function notation, f of x equals the absolute value of x minus 2. Either one of those two forms is perfect. Refreshing, guys, this last little bit, when we see minus 2, you may think, oh, that would move it left 2, but remember that sign on the inside is opposite. So we do move right 2 to get to that new vertex. Okay, example 2, we're going to follow the same process that we just did a second ago. So we're going to locate the vertex. The vertex on this graph is located here. So if I move left 1 unit and up 2 units, I get to that new vertex location. So left or right, that affects h. We moved left 1, so h is -1. K is moving it up or down. We moved up 2, so k is 2. We're always going to move from the vertex right 1 unit and see where it intersects the graph. We have to just move up 1 unit to get to the point of intersection on the graph. So A is 1. Plugging those values in, y equals 1 times the absolute value of x minus h. H is a -1 plus k. K is 2. Cleaning that up by simplifying some things. Again, I do not need to write that 1 out front. So y equals absolute value of x minus a -1. Minus a negative would make plus. And then plus 2. Making sure the graph makes sense with my equation, we see +1 here. That means the graph moved left 1 unit and up 2 units. That does correspond to my graph located on the right. Okay, on this third example, if we locate the vertex, we have to move right 1 and up 3 units to get to that next vertex. Right 1 affects the h. H is 1. Up 3, that gives me the value of k. If we move right 1 unit, notice that we have to move down 1 unit to get to that point on the function. So A for this is -1. If we plug those values in, y equals -1 times the absolute value of x minus h plus k. Simplifying things, y equals, I'm just going to put a negative sign there since it's 1. So the opposite of the absolute value of x minus 1 plus 3. Looking at the graph and how it's affected, we would move right 1 unit, up 3 units, and this -1 out front means that the graph is opening down. It reflected over that x-axis. So it's opening down instead of up, but it's not being stretched or shrunk because, again, it's the vertical difference is 1. It's just moving down instead of up. All right, taking a look at example 4, notice that the vertex is located right at 0, 0 on this example. So we do not have to move left or right, and we do not have to move up or down in order to get to the vertex. So there is no vertical translation and there's no horizontal translation. So H is 0, K is 0. If we move right 1 unit, notice that I have to move up 2 units to get to that intersection on the graph. So this one has an A value of 2. The graph is being stretched vertically by a factor of 2. If we go ahead and plug in those values, A times the absolute value of x minus h plus k. And then simplifying things, y equals 2 times the absolute value of x minus 0 is just x. And then plus 0, again, does not affect the value of the function. So just y equals 2 times the absolute value of x. So again, guys, the left or right, it is not being moved left or right. No up or down translation, only a vertical stretch by a factor of 2. All right, example 5. Locating the vertex, we have to move right 1 and up 3 units to get to that new vertex. So moving right 1, that gives me an h value of 1. Moving up 3, that gives me a k value of 3. If I move right 1, notice I have to move down 1, 2, 3 units in order to get to that point on the graph. So A is going to be -3. So we actually have two things going on with the graph with that A. It's being reflected, so it's opening down instead of up, and there is a vertical stretch by a factor of 3 there. Plugging those values into the formula, -3 times the absolute value of x minus h plus k. There's no simplifying that I can do there. That's already simplified. So just recapping what happened to the graph, we moved right 1 unit and up 3 units, and then it is being stretched vertically by a factor of 3, and it reflected. It's opening down instead of up, and that's what that negative sign does. Okay, here's the last example that we're going to walk through together. Locating the vertex, I have to move left 3 units and up 2 units to get to that new vertex. So H is -3, left 3 units. K is +2, that's up 2 units. If I move right 1 on the graph, notice that I have to move down. It's not even a whole unit. It's down a half of a unit. So A, I'm moving down a half of a unit to get to that next reference point. So A is -1/2. Plugging those values in, we have A, -1/2, times the absolute value of x minus h. H is -3, plus k. K is 2. Cleaning that up a little bit, y equals -1/2 times the absolute value of x minus a -3, makes plus minus a negative is positive, and then plus 2. Recapping what happened to the graph here, guys, this +3 indicates that I move left 3 units, up 2 units, and then this 1/2 means that it's a vertical shrink, and the negative sign makes it reflect over the x-axis. So it's opening down instead of up. It's pictured. Pause the video here, go ahead and write out those equations, see if you can find those equations, and then unpause the video to get the answers. Okay, here are the answers to those 3 U-Try questions. The first graph was shifted left 4 units. There was no up or down, and there was no vertical stretch, shrink, or reflection. So y equals the absolute value of x minus a -4, which makes x plus 4. Second example, it shifted right 4 units and down 3 units. So h is +4, k is -3. And then if we move right 1, we still have to just go up 1. So there's no vertical stretch, shrink, or reflection. So A is just +1. So y equals absolute value of x minus 4 minus 3. And then the last example, we had to move left 1 and up 2. So h is -1, k is 2. If we move right 1 unit from the vertex, we have to move up 3 units to get to that next reference point. So the A is 3. So our equation y equals 3 times the absolute value of x minus a -1, which makes x plus 1, plus 2. So again, left 1 unit and up 2 units. And this one has a vertical stretch of 3. All right, guys, this completes notes for today.